2.2 logic. This section is not bad. Got a lot of vocabulary and things to talk about. First, the statement. Sentence that is true or false. Pretty easy. Truth value. Basically whether the statement is true or what?
False.
That's what the truth value is. Negation. Opposite meaning of a statement. Compound statement. Use and, or to combine two statements. More specifically, a conjunction is a compound statement that uses and. Disjunction compound statement that uses, any guess? Or. Last thing, truth table, a way of organizing truth values into a table. Pretty self-explanatory. Now, I want you guys to look at where I have and right here. Your symbol for and is this upside down V. Okay? Your symbol for or is a V, capital V. Okay? Symbols we use for negation. Is we use that. For a statement, we use P, or you use Q sometimes, or things like that. For truth value, we do T or capital T or capital F, right? So, an example. This is our first example, example 1. For all the examples we're going to do, we're going to use this for P and Q. What I want you guys to do is write a sentence that represents each of these. Don't make this harder than what it is. See if you can do this right quick. To review, once again, what does this sign mean?
Negation.
Negation. What does this sign mean? And, right? What does this sign mean?
Or.
Don't make life harder than what it is. This, in essence, should be the easiest geometry question you get asked all year. Why do I have P beside this?
Because it's statement.
That's statement P, right? Why do I have a Q beside this?
So that's statement Q.
All I did is tell you what to write. I just used symbols. Negation is the opposite, correct? I want you to write the negation of P. Can anybody tell me what that would be?
Q.
No.
It is sunny outside.
Don't make things harder than what it is. It is not raining outside. I mean, when it's all said and done, isn't that? You know what another word for this is? Not. The negation means not. Not P, then not Q. So not would mean not to have a not, right? You see what I mean about keeping it simple? Don't make it harder than what it is. The opposite of it is raining outside is?
It is not raining outside.
It ain't raining outside, right? So what would be the negation of Q?
The sun is not shining.
The sun is not shining. We think that because it's math, it must be some complicated, horrible thing. But when it's all said and done, that's a pretty simple deal. Now look at number 3. What did I ask you to do?
You asked us.
I simply asked you to write what?
Statement P. And
P.
statement
So let's write statement P, which is it is what?
raining
Outside. Then what does this mean? And then what does that mean?
The sun is shining.
The sun is shining. Once again, don't make things harder than what they are. All I did is ask you to write that, then put a what in between them? And then write the next one. You get what I'm saying? That this may be the easiest problems you ever do in geometry all year. All I did is kind of in a different language ask you to write and in between them. And then this one, it is raining outside. What do you want me to write now?
Or the sun is shining.
I didn't ask you to tell me whether it's true or false. Don't make life harder than what it is. I just asked you to write what I have there. And if you would like, if you don't want me to own those headphones, they sure better be off your head. I don't want to see them again while I'm lecturing. That's all there is to it. Okay? Everybody look on page 101. Look at the truth tables they have here. Truth tables are made harder than what they are, but these things you see here are set in stone. Now I want you to think about this. Let's first look over here to our left. P. If our original statement is true, what would the opposite of it have to be?
False.
It makes perfect sense, doesn't it? If our original statement is false, the exact opposite would then have to be
True.
easy peasy, right? Look at this. This is conjunctions. If P is true and Q is true, then P and Q have to be what?
True.
Now, here's the key word here. In a conjunction, you've got to understand that you're using this word, and. And this, in a disjunction, you're using what word?
Or.
Now, think about this. If I ask you to take out the trash and clean the kitchen, am I giving you a choice? If you do what I ask, you have to take out the trash and you have to also what?
Clean the kitchen.
So in other words, to perform the action correctly, both of them have to be true, correct? Because that means also do this. If I said to you, you can take out the trash or clean the kitchen, what am I saying to you?
You have a choice.
I only have to do what?
One thing.
of them. I have a choice. So for you to satisfy what I've asked you to do, you only have to do one of those two, don't you? That's the difference between a conjunction and a disjunction. Notice when and is in effect, where both have to be true. The only time the compound is true is when both P and Q are both what?
True.
Look, P's Q, but Q's false. Then the compound of them can't be true because you didn't do one of them, right? This one's false, this one's true. You didn't do this one, so both of them can't be true because we're using the word and. Both of them are false, and obviously the other one's what?
False.
False. However, in a disjunction, it's the exact opposite, isn't it? The only time the compound is false is when both of them are what? Because all you have to do is do one of them, right? In this case, they took out the trash and they cleaned the kitchen, so it's true. However, here they had a choice. They just took out the trash, they didn't clean the kitchen, but because they only had to do one, they satisfied, that's true. They satisfied what they were supposed to do, right? To me, this is much easier when you don't think of it as much as true, false, as think of it done. You only had to do one of the two right. You did that one right, therefore the disjunction's right. Does that make sense? These are what you'll use when you're doing some of your homework. Okay? And here they constructed a truth table with not P or Q. So you have P can either be true or P can be false. And you're just able to construct the table, and logic leads you to one or the other. Okay? The other thing I'd like to talk about, I'm not going to write it down, is a Venn diagram. Do you guys know what Venn diagrams are?
Comparing things.
A Venn diagram is simply you use a picture. Okay, I'll use baseball players for instance. Let's say we have, this is baseball players, these are football players. Okay? What if I said right here, there's 50, right here there's 15, and right here there's 100. What do you think I'm saying with this bunch right here?
There's 15 in both of them.
They played both what? Football and what?
Baseball.
That's just a visual representation. So there's a total of how many? 65 baseball players, right? And there's a total of what? 115 football players. But only 15 of each of those play what? Both baseball and what? Does that make sense? You see the correlation there? That's what a Venn diagram is. It's a picture that basically says how things combine. You could add basketball players into that mix, just like this. You know, these would be the guys that play what? Basketball and what? These would be the guys that play what? Basketball and football. These would be the guys that play what? Basketball, football, and baseball. See the difference? See how that's what a Venn diagram is. It's a visual representation of grouping certain things. Okay? Get out your little red books for a second. Let's do a couple examples. Like I said, the best advice I can give you guys is keep it simple. Don't make it harder than what it is. They want you to do something here and then write the truth value. First of all, P and Q. 10 plus 8 is equal to 18. And September has 30 days. Would that not be P and Q? Does everyone agree? Now, truth value wise, is it true that 10 plus 8 is equal to 18? Is that true?
Yes.
So that part's true. I have the word and. Does September have only 30 days?
Yes.
That is true. So I've got true and true, so P and Q, is that true? Yes, because both were true. If one of them was false, the combination of them would be false too, wouldn't it? When I'm using a conjunction, I'm using the word and. Both have to be true. They want me to write P and R. 10 plus 8 is equal to 18, or what would be next?
A rectangle has 4 sides.
Has 4 sides. Are both true?
Yes.
Therefore, the compound is true. Because only one has to be true for or, doesn't it? Let's leave that one. Let's go to this. This says Q. Q is September has what?
30 days.
30 days. What am I supposed to put next?
Uh,
And. Now what's that little sign mean again? The negation. So the original statement is a rectangle has 4 sides. What would be the negation of that?
Does not have.
Does not have 4 sides. So let's look at this. See if this is true or false. Is September has 30 days. Is that true?
Yes.
A rectangle does not have 4 sides. Is that true?
No.
That's false. So can the combination of the two be true?
No.
Because when we use and, they both have to be true. So this one is what?
False.
You see, when it's all said and done, other than having to write things down, it's not that terrible. Okay? I expect to see this, guys, when you're writing the problems. My goodness, you think you could write that, then put an arrow, and then actually write it, couldn't you? Some of this logic stuff, there's lots of writing that has to be done. Construct a truth table for these. Truth table for each compound statement. Okay, first you have to have P, R, and then P or R. That's how you do it. Now, when you're constructing a truth table, you basically have to take into effect all the possibilities. There's the possibility that this is true and this is true, right? There's a possibility that P is true and R is what?
False.
Then there's the possibility that R is false and what?
False.
Then R is true, and then there's the possibility that both of them are what?
False.
Once you've taken care of all that, now it's just true, true. What would that make this? True. True, false, only one has to be true, so that would be true. False, true, true, false, false, false. That's all there is to it. Just have to do the possibilities. Possibility that that's true, possibility that one's true, that one's false, possibility that one's false, that one's true, and then what? False, false. This is or, so what is this? True, 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 that would be what? Not too bad, is it?